This lesson is going to be looking at transformations, specifically two types. Transformations are movements on the graph or the coordinate plane. The two types that we're going to look at, one of them is called a translation. Before I even get into what a translation is, some of you may speak another language. If you're asked to translate something, you're asked to tell the person you're translating for exactly what was said just in the language the other person speaks, right? You don't just change the meaning. So, in meaning that, if we're looking at a translation on a graph, it takes the points for whatever the figure are and it moves them in the same distance in the same direction. So the non-mathematical name for a translation is a slide. Basically, it is taking the figure and sliding it either to the left or right or up or down. It doesn't get any bigger, it doesn't turn, it doesn't twist, it doesn't flip, it doesn't anything. It's just being slid up or down or right or left. Meaning, just like the translation in words, the sentence is still the same. However, the words are just in a different location per se because they're in a different language. Then for translations, we have something called coordinate notation. Every point starts off XY, and then the little arrow is that it goes to, and then it says X plus A and Y plus B. And it tells you that A is how many units it moves left or right, because if you have a grid, this is the x-axis, this is the y-axis. The x-axis goes left or right or horizontally, so the A tells you how much you're moving the points horizontally. And the B then tells you how many, because it's y plus B, that you are moving it up or down. So let's take a look at this particular graph. It says the original is XY, just like always, and then it tells you that you're adding 5 to X and you're adding 4 to A. So let's say our original triangle is the red one. So I'm going to take each corner and I'm going to mark it with a point. And I'm going to label it A, B, C. If I'm looking at the location of points A, B, and C, I want the X and the Y coordinates. So it looks like A is at 1, 2, 3, 4, 5, 6, 7, 8. So -8. And then -7. And B would be at 1, 2, 3, 4, 5, -2. So -5, -2. And C is at -2. And then 1, 2, 3, 4, 5, 6, 7. So -7. That's where they are currently. So what happens with the translation notation is that it says that you take the X value and you're adding 5 and the Y value and you're adding 4. So if I do that, I still have A, B, and C. However, the way we know it's the new one is we put little apostrophes after them and we call it A prime, B prime, and C prime. That's the new coordinates. So I'm going to take the values and I'm going to do what the thing says. So the X value of A is -8. It says X plus 5. -8 plus 5 is -3. Y value is plus 4, so -7 plus 4 is also -3. Then I'm going to do the same thing for B and C. So -5 plus 5 is 0, and -2 plus 4 is 2. And then I have C, which is at -2, so -2 plus 5 is 3, and -7 plus 4 is -3. So that's where our new points of the blue triangle should be. So -3, -3 is here, so that would be A prime. 0, 2 is here, that would be B prime, and C is 3, -3, that would be C prime. So what you could have done is you could have taken each point and you could have literally, because this is X plus 5, so that means it's 5 to the right, and this is y plus 4, so it means 4 up. I could have taken the point A and I could have literally counted 1, 2, 3, 4, 5 to the right, and then 1, 2, 3, 4 up, and I would have gotten the same location. The second translation or transformation that we're going to look at is a reflection. A reflection is a transformation in which a figure is flipped or reflected over a line, and this non-mathematical name is a flip. So these pictures are a little bit more complex, but I want to take a second and take a look at them anyway. So we have the skateboarder. If we're looking at a reflection, the most common place that you see a reflection every day is probably in the mirror. And think about if you're wearing a t-shirt and on your t-shirt it has writing. Writing on your t-shirt in the mirror is going to appear backwards because it's flipped, right? So the same thing with a skateboarder. If we're flipping the skateboarder over the y-axis, that's this axis right here, if we're flipping the skateboarder over that line, it's going to come from the left and it's going to flip over and it's going to be on the right hand side, but it's going to be facing the alternative direction. So if we're looking at the point XY, let's just pick a particular point on the skateboarder for reference. So let's say we're looking at the point that's down here on the corner of his hand. So let's say that's point A. So we know point A prime should end up being over here, the other corner of his hand. That should be A prime. But let's see where A is. A right now, originally, is at negative 1, 1. Okay. When you reflect over the y-axis, it goes a specific place. It goes to the opposite side of the y-axis. The only thing that's different on the opposite side of the y-axis are the x values, because the y values are still the same going up and going down, but the only difference is the x values. So in the coordinate notation, it becomes then the opposite of x, that's what the negative there means, and y. So A prime should be at the opposite of x, which is this one, so the opposite of negative 1 is positive 1, and then the y is still y, so it stays the same. And if we look, A prime here is at 1, 1, just like we said it would be. The same thing goes for the x-axis, right? This is the x-axis, so I'm flipping the ice cream cone or reflecting the ice cream cone over that line. But this time, instead of it going from the left side to the right side, it's going to go from the top of the graph down to the bottom of the graph. And notice then that the ice cream cone is upside down on the bottom. So let's say we're going to use the point at the tip of the cone. And let's say that's A. Then this one has to be A prime. So let's look where A is right now. A right now is at 1, 2, 3, 4, 2. So if we're going to flip this over the x-axis, it's going to go down the bottom. Well, what changes on the bottom? Did the x values change? No, because the x values go horizontally or side to side. It's the y values. The y values, and when the ice cream cone is up top, are positive, and they become negative when the ice cream cone is flipped on the bottom. So that's why the x value for A prime should stay the same, so it should be 4, but then it says the y is opposite or negative. So the opposite of 2 is negative 2, so then my new point of the tip of my cone should be at 4, negative 2, and that is exactly where A prime is.